Now let's look at how to solve the triple integrals by using cylindrical coordinate. So in cylindrical coordinate, you are going to deal with parameters such as r, theta, and also z. Okay, so let's recall what we have learned in the Cartesian for triple integrals in Cartesian coordinate. So you will have three symbols of integrals, one here and dv. So in these triple integrals in cylindrical coordinate, you are going to replace your dv by using by using dz, r, dr, and d theta. Okay, so before we learn how to solve the triple integrals by using the cylindrical coordinate, let's look at example 2.23. This is about how to convert from Cartesian coordinate to cylindrical coordinate. Okay, page 81. So it is example 2.23, page 81. Okay, question A. So by changing to cylindrical coordinate, evaluate the following triple integrals. So this is the questions. 0 to 0, 4 minus y squared, and last one you have 0, 16 minus x squared minus y squared, and z is here, dz, dx, and dy. So you need to solve these triple integrals, okay, by using polar coordinate. First of all, let's look at what information we get from all these intervals. The first interval is the range for the z. Okay, it is from 0 up to 16 minus x squared minus y squared square root. Okay, and the second interval is the x. So for the x, you have 0 up to 4 minus y squared square root, and the last parameter is y. You have 0 up to 2. Okay, so let's compare this Cartesian, okay, dz, dx, dy with the cylindrical coordinate. So we have the dz, r, dr, d theta. So if we compare both of them, we found that, okay, for Cartesian coordinate we have dz as well as cylindrical coordinate. So we are not going to change anything for the interval for z, but we are going to change the interval for the r and theta. So before we change it, we need to illustrate this 2D figure first. So if according to the information here, you will have an equation x equals to 4 minus y squared and square root. So and y equals to y from 0 up to 2. So if we draw this function, okay, it is actually a function for a circle. So we can draw a circle. So this one will be our circle. Okay, and then we label the axis. Okay, based on this interval, the x value, the y will be from 0 up to 2. So these circles will have a radius of 2 if based on the equations, and the y will be from 0 up to 2. So I will change the color. Okay, 0 to 2, which means this part. Okay, 0 to 2. And then for the x, it will be from 0 up to equation of the circle. So this one will be your this one will be your circle. This one will be your circle, and from for x from 0 up to these equations, so we will choose the other colors. So just now I have green, okay. Now I will choose the other colors. Okay, so which means this part, okay, from 0 up to the equation of circle. Okay, so the intersection section, okay, for these two intervals will be the region that we can view from the xy projection. So if we define the interval for r and theta, okay, based on this diagram, okay, our r will be from 0 up to 2, okay, which is the radius of the circles, and our theta will be from 0 up to pi over 2, which means 90 degrees here. Okay, so now we put this interval into our triple integrals. So 0, pi over 2, and we have 0, 2, and for the z we remain it to be 0, 16 minus x squared minus y squared. Okay, we just remain it, and I will have a z here, and dz r dr d theta. So you can start solving these triple integrals. And this one will become z squared over 2, and you have the interval 16, and 2, sorry, this is 0, okay, and you have r dr d theta. Okay, you have settled the first integrals, then you find the simplify the integral, so it will become 16 minus x squared minus y squared, divide with 2, and here you have r dr d theta. Okay, since you are going to solve these double integrals by using cylindrical coordinate system, so you have to replace all the x and y into r of theta. So for this case, it will become 6 minus r squared, divide 2, and you have r dr d theta. Okay, so for the integrations with respect to the r, you can press your calculator to get the answer. So you will get 14 here, d theta, and it will become 7 pi. Okay, so this one will be your answer for these triple integrals that you solve it by using the cylindrical coordinate. Let's look at the next example, which is question B. So this is your question B. We have a square root, x squared plus y squared. We have 1 here, so here also x squared plus y squared, dz, dy, dx. Okay, since we are not going to do anything for the z interval, so this part I will not write it. So for the y interval, it will be from 0 up to 1 minus x squared. And for the x, okay, it will be from 0 up to 1. Okay, so if we examine this interval, we can get a function which is y equals to square root 1 minus x squared, and it is actually a circles with radius 1. So you draw your circles here. Okay, so this one will be your circles. This one will be your circles. Okay, now you need to define the region. Okay, the region wanted by the questions. Okay, refer back to your interval. Y will be from 0 up to the equation of circle. So here I will use different colors to represent these regions. Okay, Y is 0 will be equals to here, and Y equals to the curve of the circle will be this one. So I will shade this region. Okay, next we move on to the next interval, which is X. So for the X, it is from 0 up to 1. So here I will change the other colors. Change the other colors. Okay, X 0 up to 1. Okay, this one is the radius of the circle, which is 1. Okay, so this one will be the intersection point, intersection region between these two intervals. Okay, so now we have to define the interval by using the polar coordinate or cylindrical coordinate. So your R will be in between 0 up to 1, and the theta still the same, 0 up to pi over 2. Okay, up to pi over 2. Okay. So if you put this thing in your triple integral, 0 pi over 2, 0, 1, and the z will remain, which is from x squared plus y squared equals to 1. And here you have x squared plus y squared, dz r dr d theta. Okay, you can convert these two parameters into r squared. Okay, so you will have r squared dz r dr d theta. So you will have r squared 1 minus r squared. Okay, 1 is from here minus r squared, because after you integrate with respect to z, you will have one more z here. Okay, r dr d theta. So no more this one. Okay, no more this one. Now you are going to integrate with respect to the r. Same thing, please press your calculator. You will get your answer 1 over 12 d theta. Okay, so you will get your answer, which is 1 over 24. Sorry, pi over 24. Okay, so this one will be your answer. Okay, so these two shows how to convert from Cartesian coordinate to cylindrical coordinate. Okay, now let's move on to the example 2.24. Okay, so this example, we are going to solve the volume of the paraboloid by using the polar coordinate. So example 2.24. Okay, page 82. Okay, simple one. Okay, the paraboloid function is z equals to 25 minus x squared minus y squared. And it is above the xy plane, okay? So let's draw this paraboloid. So if you don't remember, okay, the meaning of this function, you can use the contour plot or the level curve in order to get some idea what is the shape of the 3D structure. Okay, so now here I will not show the step because I assume that you have know all these things because you have tried it in test 1, right? Okay, so this one is a paraboloid. Good. Okay, so this one is a paraboloid. So here will be your z, and here will be your y, and here will be your x. So above the xy plane. So I didn't extend the drawing in the negative z-axis part because it is above the xy plane. So let's label the value that we know. Okay, so this is a circle. So this circle exists at the height equals to 0. So it will have a radius of 5. And at this point, the x and y, they are both 0. So your z will be 25 here. Okay, so let's look at the equation to find the volume. So you have triple integrals and you have 1 here. You need to define the interval for z, for r, and also for the theta. Okay, so here we will choose the xy projection like usual. Okay, xy projection. So when we view this 3D structure from top, we can see a circle. So xy projection will show us a circles actually. So you draw your circles. Okay, a complete circle, x and y plane. Okay, so since this is a complete circle, your radius, okay, your r interval will be from 0 up to the radius of the circle, 5, and your theta will be from 0 up to 2 pi. Okay, next you have to define the interval for z. Okay, you assume yourself is inside this 3D structure, and when you refer down, you see a horizontal surface, a flat surface, okay, appears at height z equals to 0. So your z will be from 0 up to what? Okay, up to this surface, which is the surface from the paraboloid, and its equation is represented by this one. Okay, so you put your equation here, 25 minus x squared minus y squared. It is actually very similar to the Cartesian coordinate, just now the structure, they are mostly circles. So you define the interval r and theta based on the region wanted by the questions. So these are the intervals. So you put the intervals into the triple integrals. So in order to find your v, so this one will be v, 0 up to 5 is the radius, and 0, 25. Okay, because you know you are going to solve by using the r and theta, right? So this one you can automatically change it to r squared. Okay, and here will be 1. You have dz, r, dr, d theta. Okay, so you solve these triple integrals. 0, 5. This one will be 25 minus r squared. You have settled this one, and you have r here. Okay. Okay, don't forget the bracket, dr d theta. Next, you press your calculator for the answer. The answer is 625 over 4 and d theta. Okay, so when you multiply with 2, you will get 625 over 2 pi. Okay, so now you are calculating the volume, so you have to throw up with its unit, okay, which is unit cube. Okay, we try one more questions, which is example 2.26, page 83. Example 2.26, page 83. Okay, question A. Okay, find the volume of the solid bounded above. Okay, you must be used to the wording such as bounded above, below, by what. You have to use to this kind of sentence in order to identify the correct region. So this is bounded above by this one. Okay, in other words means this structure atas dia ditutup oleh atau di-cover oleh this one, and below by plane XY. Okay, this is below, bawah dia ada plane XY, and the side by cylinder x square plus y square equals to 9, and this is a cylinder. Okay, this is a cylinder. So first of all, you need to construct this 3D structure. So you have to know what is this shape. Okay, so by assuming z equals to 0, what you will get, z equals to 4, what you will get, z equals to 3, what you will get. So it is actually a paraboloid. So you sketch the paraboloid. Okay, sketch the paraboloid. It is not a straight line. It is not a straight line, it is a curve. Okay, it is a curve, not a straight line. Okay, curve. And after that, you have the XY plane. XY plane is somewhere here at the bottom, I think, and every of you know what is the XY plane. So I'm going to draw it. Okay, and below by the XY plane, side by the cylinder. So cylinder, you will have a radius. So we have to draw a cylinder. So I would like to draw a cylinder. So this one will be the cylinders. Okay. So you will have a cylinder here. Okay, straight lines here. Okay, so things will be like that. So bounded above by this paraboloid, okay, side by the cylinder, below by the plane. So it means now the area that you need, the region that you need to find is its volume will be here. Sorry, will be here. Can you imagine? Okay, so now we need to define the interval. Okay, we need to define the interval. If we have the XY projection, we will see a circle, right? Okay, so when you see a complete circle, so the interval for the r will be from 0 up to the radius of the circle, which is 3, and the theta will be 0 up to 2 pi. Okay, next we have to define what is the interval for our z. Okay, z. So you have to assume yourself is inside here. Okay, any place. When you refer down, you see a flat surface at the height z equals to 0. Okay, so when you refer up, you actually see this paraboloid. So the equation of the parabola is this one. So you will put it here. Okay, now you insert all these intervals into your triple integrals. 0 to pi, 0 up to 3, and 0. X squared plus y squared, you can change it to r squared, and here will be 1 dz r dr d theta. Okay, you can solve these triple integrals, and here you have r squared. Okay, no, multiply with this one, you will have r cubed. No, r cube, yes, r cube, and then dr d theta. Okay, you can press your calculator. The answer will be 81/4 d theta, and it will be 81/2 pi unit cube. Let us have one more example, example 2.28. Here in your module, page 84. Okay, let's look at question A. By using suitable triple integrals, find the volume of the solid bounded above by hemisphere. So you will have a hemisphere above by a hemisphere, which is z equals to 25 minus x squared minus y squared, and then below by xy plane, and side by cylinder. Okay, very similar to the previous question, but the structure might be slightly different. Okay, you have to look at it. Cylinder with the equation x squared plus y squared equals to 9. So you start to draw it. First of all, you need to identify what is this. Okay, so this is a hemisphere, right? Hemisphere, so we have to draw a hemisphere. It will be a hemisphere. Okay, okay, and then below by xy plane, so this one will be the xy plane, and side by a cylinder. So this cylinder has a radius of 3. So let's label what will be the value here. So if you refer to these equations, when the z is 0, okay, when the z is 0, 0 equals to 25 minus x squared minus y squared. Okay, this means that your radius will be square root 25. is square root 25 is square root 25, which is 5 lah. Okay, so here will be 5, here will be 5. It is a hemisphere, so this point you will also have value 5. Okay, so this is 3. So now we have to draw the cylinder here. Okay. It can be up to infinity, so this one I will draw it. So I will draw a straight line. Okay, so you have to identify which is the place they want you to find the volume. Okay, so we have to shade it. So this one will be the region. Okay, from top view, okay, look at the XY projection. You will see a circles with radius 3. So I don't draw it anymore. So I define the radius 0 up to 3, complete circle. So it is 0 up to 2 pi. And when you refer up, okay, you see the surface, okay, from the hemisphere. And when you refer down, you see a flat surface at the height z equals to 0. So it will be from 0 up to 25 minus x squared minus y squared. Okay, so this one is your hemisphere. So you put it into your triple integrals. Okay, 0 2 pi 0 3 0 25 minus x squared minus y squared. Okay, this one we can simplify to be r squared. Okay, r squared. You have 1 dz r dr d theta. Okay, so solve it like usual. 0 2 pi 0 3, so 25 minus r squared, and you have r dr d theta. So you can press your calculator for answer. Your answer is 61 over 3 d theta, and it will be 122 over 3 pi unit cube. Okay, so this one will be your answer. Okay, so you have tried a few examples how to solve the volume by using triple integrals, cylindrical coordinates. So it is actually very similar to triple integrals by using Cartesian coordinate. You can try more exercise in the module to get more understanding. So we will try the tutorial later on.